We often see electric poles set up at regular intervals alongside roads. To determine the length of the cable between two electric poles, you measure the space or the distance between them. Consider a situation where you need to determine the length of cable required to lay electric lines between multiple points in a locality. If you create a map of the locality and transpose it onto a graph, you can derive the formula to calculate the distance between any two points in the locality. Welcome to the lesson, Distance Formula. In this lesson, you will learn how to apply the distance formula in coordinate geometry. At the end of this lesson, you will be able to apply the formula for calculating the distance between two points. Examine the corollaries of the distance formula. Consider the locality shown in the map. A power station is positioned centrally in the locality. The power station is laying cables to supply power to a new school and a stadium. The cable lines will go to the school via the stadium. The electricity department charges customers on the basis of the length of the cable required at the rate of 10,000 rupees per kilometer. Determine the expenses incurred by the school authorities for laying the cable. To determine the length of the cable required, we need to find the distance between the power station and the stadium, and then the distance between the stadium and the school. If the map is transposed onto a graph, you can derive the formula to find these distances through coordinates of various points. We can take the power station as the origin in the graph, as it is centrally located. First, let us derive a generic formula to obtain the distance between any two points with the help of their coordinates. In the graphical representation of the distance formula on the screen, let point P, x1, y1 represent the stadium on the graph, and point Q, x2, y2 represent the school. To find the distance between points P and Q, we draw a perpendicular line from point P to the x-axis. This line intersects the x-axis at point R. We draw another perpendicular line from point Q to the x-axis. This line intersects the x-axis at point S. The x-coordinate of P is x1. This denotes that the distance from origin O to point R on the x-axis is x1. Similarly, the x-coordinate of Q is x2. This denotes that the distance from origin O to point S on the x-axis is x2. Now, the length of RS can be determined. RS equals OS minus OR, which is x2 minus x1. Next, we draw a perpendicular line from point P to line QS intersecting at point T. If you notice, the distance from point P to R is y1, because the y-coordinate of P is y1, which is equal to ST. Similarly, distance from Q to S is y2. Therefore, distance TQ equals SQ minus ST equals y2 minus y1. Distance RS is equal to distance PT, which is equal to x2 minus x1. As you can see, PTQ is a right-angled triangle. Pythagoras' theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Therefore, in triangle PTQ, the square of PQ is equal to the sum of the squares of PT and TQ. On substituting the values of PT and TQ, you get PQ equals square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. Therefore, the distance between any two given points on a graph can be calculated using the formula square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. Let us refer to the graphical map that shows the power station, the school and the stadium. Since the cable has already been laid from the power station to the stadium, the power station will lay the cable from the stadium to the school. To calculate the length of the cable, we will calculate the distance between the stadium and the school. In the graph, the coordinate of the stadium is 3, 4 and the coordinate of the school is 6, 8. According to the given data, the cable costs 10,000 rupees per kilometer. Stadium P is at 3, 4 and school Q is at 6, 8. The distance between the stadium and the school is represented by line segment PQ. The formula for calculating the distance is square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. Substituting x1, y1 equals 3, 4 and x2, y2 equals 6, 8 and simplifying, you get distance PQ as 5 kilometers. Therefore, the total expenditure incurred by the school authorities for the cable will be 50,000 rupees. Using the same method, we can find the distance between any two points in the given locality. For instance, consider the length of the cable laid from the power station to an auditorium as shown on the map. On the graph, the power station is at the origin 0, 0 and the auditorium at -9, -12. The formula for calculating the distance is square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. When you substitute x1, y1 equals 0, 0 and x2, y2 equals -9, -12 in the formula and simplify, you get the distance of OA as 15 kilometers. Thus, the distance between the power station and the auditorium is 15 kilometers. Thus, you can find the distance of any two points using the distance formula when the coordinates are given. The distance formula can be further simplified for specific scenarios. For instance, to find the distance of a point from the origin, that is, the center of your graph, you can use the following formula, square root of x squared plus y squared. To verify this, let us consider again the problem where we calculated the length of the cable laid from the power station to the auditorium. On the graph, the power station is placed at the origin 0, 0 and the auditorium at -9, -12. On applying the formula square root of x squared plus y squared, you get length OA is equal to 15 kilometers. As you can see, the values obtained using both the formulas are equal. So far, you have been calculating distances between two points. However, there may be cases where we have three collinear points on a graph. According to a corollary of the distance formula, where 3 points on a graph are given, and the sum of the distances of 2 points from a third point is equal to the distance between the first 2 points. The 3 points on the graph are collinear. For example, in the given figure, the 3 points A, B and C are collinear if the sum of the distances between A and B and C is equal to the distance between A and C. In other words, the 3 points A, B and C are collinear if AB plus BC equals AC. Consider the distances between the power station at origin O 0, 0, the stadium P 3, 4 and the school Q 6, 8. Apply the distance formula for the points given. You can calculate OP, PQ and OQ. Thus, OP is equal to 5 kilometers, PQ is equal to 5 kilometers, and OQ is equal to 10 kilometers. As you can see, the sum of OP and PQ is equal to OQ, and the power station, the stadium and the school all lie on the same line. That is, they are collinear. The electricity board is setting up an electric tower between two villages. The ratio of the distance between the tower and the two villages is 2:1. If we plot the villages and the tower on the graph, can we find the exact location of the tower? In this lesson, you will learn about the section formula. At the end of this lesson, you will be able to derive the section formula, apply the section formula to find a point that divides a line segment in the given ratio, and identify the corollaries of the section formula. Given the two endpoints of a line segment, you can determine the coordinates of the point that divide the line segment in the given ratio using the section formula. Let AB be a line segment. The coordinates of the points A and B be x1, y1 and x2, y2 respectively. Let the point P x, y divide the line segment in the ratio m:n. Now, let's see how we can derive the formula to find the coordinates of point P. We need to find the x and y coordinates of point P using the values of m and n, and the coordinates of point A and B. First, we draw perpendiculars from points A, P, and B on the x-axis. The points where these perpendiculars intersect the x-axis are named Q, R, and S respectively. Then we draw AC perpendicular to PR and PD perpendicular to BS. Two triangles ACP and PDB are created. You will observe that angle ACP is equal to angle PDB, that is 90 degrees. Angle PAC is equal to angle BPD. Based on the angle-angle AA similarity criterion, we can conclude that triangle ACP is similar to triangle PDB. Since one of the angles is 90 degrees, they are similar right-angle triangles. In similar triangles, the ratio of the corresponding sides are equal. This leads us to equation 1. AP divided by PB is equal to AC divided by PD is equal to PC divided by BD. As you can see from the graph, AC equals QR. QR is equal to OR minus OQ is equal to X minus X1. Thus, AC is equal to QR is equal to OR minus OQ is equal to X minus X1. Similarly, PD is equal to RS. Thus, PD is equal to RS is equal to OS minus OR is equal to X2 minus X. Now let's move on to determine the heights of both the right-angle triangles. PC is equal to PR minus CR is equal to Y minus Y1. Similarly, BD is equal to BS minus DS is equal to Y2 minus Y. Earlier, from equation 1, we get AP divided by PB is equal to AC divided by PD. Substituting the values of AP, PB, AC and PD in the ratio of the corresponding sides, you get m divided by n is equal to x minus x1 divided by x2 minus x. Rearranging the expression, you get x multiplied by m plus n is equal to mx2 plus nx1. Simplifying the expression, you get x is equal to mx2 plus nx1 divided by m plus n. Similarly, you can substitute the values for sides PC and BD. From equation 1, AP divided by PB is equal to PC divided by BD. Rearranging the expression, you get y multiplied by m plus n is equal to my2 plus ny1. On simplifying, you get y is equal to my2 plus ny1 divided by m plus n. Thus, the coordinates of point P can be calculated using the formula obtained: mx2 plus nx1 divided by m plus n and my2 plus ny1 divided by m plus n. This formula is called the section formula. According to the section formula, any point P, x, y dividing a line segment in the ratio m:n can be represented as mx2 plus nx1 divided by m plus n and my2 plus ny1 divided by m plus n. By applying the section formula obtained, you can now determine the exact location of the electric tower. Let's review the problem again. The village A is located at 2, -1 and village B at 5, 2. The distance of the tower from village A is twice the distance of the tower from village B. If the map of this region is transposed onto a graph, find the exact location of the tower. According to the problem, coordinates of village A, x1, y1 is equal to 2, -1. Coordinates of village B, x2, y2 is equal to 5, 2. The ratio of the distances of the tower from villages A and B, or m:n equals 2:1. Substituting the coordinates of A, B, and the ratio m:n in the section formula, you can determine the coordinates to specify the position of the tower. Simplifying, you get the coordinates of P as 4, 1. The electric tower is located between villages A and B at 4, 1. Some corollaries to the section formula can be derived for some specific cases. According to the first corollary, where the ratio of sections of a line segment m:n equals 1:1, the point is the midpoint of the line segment. In such a case, the midpoint of a line segment joining x1, y1 and x2, y2 is x1 plus x2 divided by 2, y1 plus y2 divided by 2. The second corollary relates to the coordinates of the centroid of a triangle. The centroid of a triangle is the point of intersection of its medians. The centroid of a triangle divides the medians in the ratio 2:1. Thus, based on the section formula, centroid G of a triangle with vertices x1, y1, x2, y2 and x3, y3 is x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3. Welcome to the lesson on area of a triangle. At the end of this lesson, you will be able to derive the formula for the area of a triangle for which the vertices are given on a Cartesian plane and apply the formula to calculate the area of a triangle. Here are two triangles, triangle ABC and triangle PQR. Consider the triangle ABC. The length of the base AB and the corresponding height CD are given. Next, consider the triangle PQR. Here the length of the sides PQ, QR and PR are given. How will you find the areas of these two triangles? We can calculate the area of triangle ABC by applying the formula half the product of the base and its corresponding height. To calculate the area of the triangle PQR, we can apply Heron's formula. This formula uses the semi-perimeter and the lengths of the sides of the triangle to calculate the area. Now look at this triangle. Oh, where is the triangle? All we can see here are 3 points, A, B and C. Let's join the points A, B and C. Here's our triangle ABC. Now, how do we calculate the area of this triangle? There is a method to calculate the area of any triangle when the vertices are given as points in a Cartesian plane. Let's derive a formula that will help us calculate the area of the triangle in terms of the coordinates of vertices A, B and C. Let's see how. The coordinates of point A are x1, y1. Point B are x2, y2. And point C are x3, y3. Let's derive a formula to calculate the area using these coordinates. Draw perpendiculars from the points A, B and C onto the x-axis. Mark the points where the perpendiculars meet the x-axis as L, M and N respectively. 3 quadrilaterals ABML, ALNC and BMNC are formed. Now let's observe the complete figure. Here, if we remove the area of quadrilateral BMNC from the sum of the areas of quadrilaterals ABML and ALNC, we get the area of the triangle ABC. Let's first calculate the areas of the quadrilaterals. In all 3 quadrilaterals, ABML, ALNC and BMNC, a pair of sides are parallel. In the quadrilateral ABML, BM and AL are parallel. In the quadrilateral ALNC, AL and CN are parallel. And in the quadrilateral BMNC, BM and CN are parallel. All 3 quadrilaterals are trapeziums. Therefore, our equation changes as shown. The area of a trapezium is given by half the product of sum of parallel sides and the distance between the parallel sides. In the quadrilateral ABML, the side BM is y2, AL is y1. The distance between BM and AL is ML, that is x1 minus x2. Therefore, the area of trapezium ABML is half multiplied by y1 plus y2 multiplied by x1 minus x2. Similarly, the area of the trapezium quadrilaterals ALNC is half multiplied by y1 plus y3 multiplied by x3 minus x1. Similarly, for the area of trapezium BMNC is half multiplied by y2 plus y3 multiplied by x3 minus x2. To obtain the area of the triangle ABC, add the areas of trapeziums ABML and ALNC and subtract the area of trapezium BMNC. We will get the following expression. Let's further simplify this expression. Expanding the expression and then cancelling the like terms, we get the following expression for the area of the triangle. Therefore, this expression can be used to calculate the area of the triangle given its vertices as coordinates. An important point to note here is that if the area of the triangle obtained is 0, then the 3 points are collinear. You have reached the end of this section. Before moving on to the next section, let's recap the key points covered. The area of a triangle of which the vertices are given as points in a Cartesian plane can be calculated by the following formula. An important point to note here is that if the area of the triangle obtained is 0, then the 3 points are collinear. Hope you enjoyed your learning experience.